Hello and welcome. My name is Matt Hamilton from the Arbitrum Foundation, and today I'm joined from Howard and David from Lit. Before I get them to introduce themselves, just give me one moment here while I just give us a rundown of where we are with this. This is now our 5th episode of this series. This is our Stylus Showcase series, in which we've been going through with various developers that are building on Stylus out there in the real world, what it is they're building, how they're building it, how they're getting on with Stylus, why they're choosing Stylus, that kind of thing, right? So, like I said, this is the 5th in a series. We've also had a previous Pro series as well, Stylus Pro series. Both this series and the Pro series you can find on YouTube. We're live on YouTube, Sanko, and on X at the moment. We also have a number of events coming up. So we've got the Road to DevCon event coming up. So we have Jakarta this weekend, and then we have Ho Chi Minh City the weekend after that. So that's a series we've got called RB Link that's happening in person there. We then have the Edge City Lana Hackathon happening in Chiang Mai at the start of November. And we have DevCon happening in Bangkok, and then ETH Global Bangkok. So we've got a whole lot of stuff coming up for developers, all coming up for the rest of this year. So with that said, on to talking about Lit. And we've got David and Howard here. So thanks, folks. Thanks for joining me here. And do you want to give just a quick intro about yourselves and maybe start with like a rundown about Lit once you're done with that?
Howard, you want to start with your intro and then I can give the update on what we're up to?
Yeah, sounds good. Thanks for having us, by the way. I'm Howard. I'm a senior protocol engineer at Lit. I've been with Lit since August 2022, and I work across the entire stack, but primarily focused on the node protocol itself. David?
Awesome. Thanks, Howard. And yeah, thanks, Matt and the Arbitrum team for having us. I'm David. I'm one of the co-founders of Lit. And I'll just take a couple minutes to describe what we're up to, and then we can get into some of the Stylus specifics. So I'm going to attempt to share my screen. Is that coming through for you?
So I think we just need to get Churro to bring that up onto the screen. Churro's there. Yeah, there we go. So yeah, I can see that now.
Excellent. Right. Yeah, so this is a quick high level on what we're up to. The fundamental problem that we're after here at Lit is something that is broadly recognized, which is across blockchains, across platforms, across identities, across devices, we live in a deeply, deeply fragmented world. And this is something that not just developers know, but literally anybody who is involved in society in any kind of way has a sense of this frustration, of the disconnected nature of all of these systems. And we know collectively, as people who are technologists, the type of future that we want, which is one where agents, applications, protocols, intelligent companions can work on our behalf as either as individuals or businesses across all of these systems. And so what ties all of these together, it's not actually a secret, but is in fact secrets for authentication. And so the fundamental idea behind Lit is that if you can create a programmable and distributed secret, you can program your application or agent or protocol to interact across every system. This includes things like chain abstraction, bringing AIs on chain, compute over private data. And so here's some teams that are leveraging this, but this is what I want to get to. The way that this system works is there's a network, and this is moving in order of scale from left to right. So you can see here over on the left side of the screen, each Lit node consists of a sealed hardware environment with 3 components within it: a key share, an execution module, and a networking module. And the key share is part of a threshold key network, which is demonstrated here. And what you can see outlined in green is a 2/3 threshold. So in order for any operation, like signing something or decrypting something, to happen with the distributed key stored as shares across these nodes, a threshold or 2/3 of the network needs to authorize that in an automated way from within the sealed hardware environment. And so this is functionally and fundamentally What we've built, we've had the mainnet beta out since February of this year, 2024. To date, the network has processed over 20 million transactions, again, across private data, chain abstraction, user onboarding, and I'm sure we'll get into some more of the details, but just to kind of future cast a little bit, really what we see is just a whole new era and epoch in the way that individuals and the AI companions that they're associated with interact with every single system by virtue of being able to have a secret that is non-custodial, which is to say not controlled by a centralized party, and then a user being able to run applications on top of that secret that in turn interact with all of the systems, crypto networks, Web2 platforms, centralized stock exchanges, and so on.
Okay, cool. Yeah, so I mean, I'm old enough to have been dealt with things like Kerberos and stuff like that, and it's kind of like this has been a perennial problem, right, in computing and in how people interact with services is to do with authentication and authorization. And like I said, we've gone through in the desktop world things like Kerberos, and then we've gone things like OAuth in the Web2 world and that kind of thing. So I guess where we're looking at now is how to deal with like the security, like you said, the key management in a more decentralized way, in a Web3 native way for that. So that's really cool.
That's right, Mark. And the big insight there is that it's the same insight that Vitalik had, which is setting up a network, whether it's a blockchain network or a decentralized key management network. It is a lot of work. As mentioned, we've been at this for over 3.5 years. And Vitalik's insight in many ways is setting up a blockchain is hard if you enable the ability to program state, which is the invention of the smart contract and the smart contract platform. Now people can leverage distributed and decentralized state without having to set up a node network by launching a smart contract. Lit works very similarly, except rather than managing state in the context of a ledger, it's managing secrets such that any developer can come in and articulate programs and AIs that dictate how this distributed key will sign things, encrypt things, and authenticate with various systems.
Cool. Yeah. And then, so, okay, great. So then moving on to Stylus itself, how are you leveraging Stylus? What is it that's sort of drawing you towards Stylus?
Yeah. So when we talk about programmable keys, there's a great deal of permissioning and management being done on chain right now in our smart contracts. So we use smart contracts for a lot of the consensus that the nodes would need in order to function properly as a network. Right now, each lit PKP or programmable key pair, as we term it, has a unique public key in order to use them. We mint a transaction on to the smart contract in order to create a new PKP, and then a separate smart contract called the PKP permissions manages the permissioning of that. We use these contracts to derive the public key of each individual programmable key pair. And actually, Stylus is used to allow us to write Rust smart contracts that are deployed as Stylus contracts, which allow us to implement and leverage this key derivation logic that is written in Rust. So that's in short how we use it, but we can certainly dive into the details later on.
So did you already have like code in Rust? Was that like one of the draws to this as well, or modules you were using or leveraging that existed already in Rust?
No, we didn't actually, and we previously we can go into it more too. We have a rather long history of how we got here. We originally were writing in some Golang code, and then we're very much a Rust shop, and so being able to leverage the same programming language throughout is a huge unlock for us.
Right. That's pretty cool. And yeah, there's we've said this a few times on a few other these episodes, but there's about something like 30,000 Solidity developers worldwide, and about 15 million, well, about 3 million Rust developers worldwide, about 15 million when you take Rust, C, C++ together, that Stylus is unlocking, right? So that's a huge pool of talent that's then able to kind of build smart contracts directly on there. Okay, so in terms of like a chain, why did Lit even need a blockchain for what they were doing with this the key management and stuff, so that side of things.
Yeah.
Yeah.
Go ahead, Howard.
Go ahead.
Oh, sure. Yeah. Okay. I'm curious about your perspective as well. But basically, like as we've been over, the whole idea here is that there's not a centralized holder of these keys. The secrets are not bound to a specific provider, aka like a node operator. And the key shares themselves are also not bound to a provider. So there's this distributed network of various parties and stakeholders, and they functionally need a database. And so Lit is using a blockchain in like truly an app chain type of way, where the blockchain is functionally the backend for these distributed signing nodes. And so we're not motivated to like get teams to launch dApps on this chain or anything like that. The teams that are building on Lit are writing programs that run in the MPC network, but the backend, the database for the nodes to communicate with each other, and then Howard, flip it over to you if you want to fill in some more details, is a blockchain is just the obvious choice of the database type to use there.
Yeah, the real unlock that this architecture that we currently have is that it's quite simple. It's not that, without Stylus and without a blockchain that we can't do things, but we'd have to almost redo certain parts in the node level. Right now, we're using the chain for the consensus data layer for, like I said earlier, the PKP management of these PKPs itself, and also the permissioning of bits of these key pairs. What this allows is that this allows the nodes themselves that inside the T's, they only keep state of the key shares, nothing more. And so with respect to the flow of using these PKPs, it becomes a stateless flow. And so we can, simplify the architecture more is a huge motivation to why we're having this right now.
So just to bring up, you mentioned T's there, T's trusted execute environments. So these are like secure enclaves that are running within processors. So are these specific nodes that you're running for this network then that have these secure enclaves available?
Yeah, I'll go back to the screen share real quick just to show that. So the security, I don't know if the screen is up again, but the security model here because like the fundamental question is, how do you keep key material safe?
Right.
So the first step is you divide it up into parts via this threshold mechanism with the key share. But then the next threat is, well, what if these node operators want to collude with each other and basically make a deal to say, hey, let's steal this key material, which would be an existential threat and fully undermine the network. So that's the use of the TEE, or the sealed hardware. It's not technically an enclave in this case. The processor that's being used here is something called AMD Secure Encrypted Virtualization. So it's a fully encrypted VM, but functionally it ends in the same space, which is essentially creating a black box that the node operator creates an attestation of the operating system that they're running inside of this. And so if a node operator were to modify that underlying operating system, they would not be able to produce the cryptographic attestation, and therefore would not be able to join the network and get access to the key share that lives inside of that sealed hardware, or TEE.
Right. Okay, cool.
Cool. And just to tag on a couple more points to your original question, why do we even need a chain to build on? We also have other considerations apart from the architecture. We need a chain that is cheap and fast for us to use. And previously I mentioned, we've come a long way to using Arbitrum today, right? A long time we were on Celo. We were eyeing it. We were using it for how cheap it was. And then we later moved on to the OP stack, the Optimism stack, because at the time they had a relatively decent DevX for building in the necessary precompiles we needed for our PKPs, right? Precompiles are what I was referring to previously as the custom code that we need to derive public keys for our PKPs. And then at some point we reached the limits of the OP rollup, of the optimistic rollup, and we needed an even better solution. And so we started to look into Arbitrum. And so, on one hand, you have optimistic rollups that have 2-second block times. Arbitrum has almost instantaneous confirmations. And this was, really, really great signals for why we really need to double down on this and this direction. And, we noticed that from a cost standpoint, it's significantly cheaper than the OP stack too. So this was adding up to be really usable for both us and also for users of our platform. And then lastly, to talk about DevX as well, we need a chain that allows us to move fast as a team. So when we're using OP stack, every time we needed to add or change the precompiled code, we needed to coordinate with our rollup provider. At the time, we were using Caldera, and this whole process, this whole cycle involves us, writing a proof of concept and then shipping over to them, and then their team would need to build and upgrade the chain. The whole coordination between external teams is very lengthy and error prone, more error prone than if you were to just communicate internally. And so, being able to work now with Stylus, precompiles are just a Rust contract, a smart contract, right? You can just deploy a new one and start using it. It's a huge unlock for us.
Yeah, that's a great thing. We've heard that before from others as well, and it's not something I kind of really considered, but it gives you a nice space between your sort of regular smart contracts and your precompiles, where you can build with, like you said, not having to upgrade the whole network. I mean, even if you're using a roll up as a service and you have your own chain, I mean, that's the best position to be in that case, but you've still got to upgrade the whole network. You've got to coordinate the nodes. You might need some kind of governance vote or coordination across the node providers, and if you try and do that on a public chain, that's going to be near impossible to kind of do that at least in any time frame that you want to do, right? So the fact that Stylus is available on like not just your own chain if you're doing stuff via Orbit, but also the public chains like Arbitrum 1 and Arbitrum Nova, means that you can get like the power of precompiles yourself without having to fork the network, get consensus, upgrade the RBOS, all of that kind of stuff that you have to do. So that's definitely a really powerful thing there.
And that's only referring to production environments. When we talk about DevX, we also talk about, well, what happens during testing in local environments, right? So for the longest time, we currently still need this to an extent. We've had to fork Anvil from the Foundry stack to maintain our own fork to include the precompiles, right? And at that point, we started to write in Rust, but being able to just switch to a model where we don't need to maintain a fork, because there's a whole host of maintenance and problems that you can come into when you're maintaining your own fork, which is a discussion for a separate time. Being free from that constraint and just saying, hey, we're using the same tool, same product, but it's just the new changed precompile code is just a new smart contract you can point to, and you can treat it as just any arbitrary contract to contract interaction. That's beautiful.
No, that is really cool. And so it's not just the production chain, but your testnet chains, all of that lot as well. So you're dramatically reducing the amount of kind of maintenance, headache you have to keep everything up and going, just to do this, and to sync things like your, precompiles on testnet with production as well, all that kind of, your promotion process for migrating from one to another. That's all really cool. So, kind of apart from that, the sort of the precompile aspect of things, are there any specific like features or capabilities of Stylus that like attracted you to it? I mean, you mentioned a bit that you're a Rust shop already before. So did that play into it as well?
Yeah. So, being able to write in Rust and then compile down to WASM, which is deployed as a smart contract, that, like you said, huge unlock. Secondarily, we also have noticed that, just the fact that there is built-in interoperability between Solidity and Stylus smart contracts makes it so easy to consider this as an option for us to use, right? Also noticing that the WASM VM, compared to using the EVM for these precompile logic, we get cheaper and faster execution of the precompile code. So that's also really, really good. And that was really attractive for us to consider Stylus. And then lastly, I think last major point to mention is just the good documentation and the hands-on support that resulted in us having an overall pretty pretty good DevX and easy to build a POC for us to prove that, okay, this thing actually indeed works with Stylus, and then actually taking it through to integrating to what we have now in our production network.
Cool. Yeah, that's I was just doing some Solidity stuff yesterday, which I kept hitting stack limit errors on the EVM. I was like, damn it, if I was writing this in Stylus and Rust and for that particular case, which it will be eventually, that would have made that a lot easier. But like you said, the interoperability, the composability, another smart contract written in Solidity and to the EVM doesn't even need to know that what it's calling is in Stylus and written in Rust or executing on the Wasm VM. It just knows, okay, there's a smart contract at this address. You've got this ABI or whatever that you need to call and these functions you need to call. It doesn't even need to know. And that's great, because especially for when you're looking at like the rest of the ecosystem and the partners within a chain, you've got a DEX, for example, and they've got a hooks. So Uniswap v4, for example, has got hooks, right? And people are writing those hooks in Solidity. Well, you can write them in Stylus, and Uniswap doesn't even need to care, right? And I think the same way with Lit, with what you're doing, any other interaction you're doing, whether you have calls both in or out of Lit to other smart contracts, it doesn't matter whether that's Stylus or Solidity from the developer's point of view who's calling it.
Yeah. Especially when you're integrating simple concepts like proxy contracts, you start to be able to just really pave the way for upgradability of smart contracts, and also immutability too, right? Like you can also, that's never really have gone away or compromised in any sense, but from a kind of agnosticity standpoint, you make it much more simpler to reason about things on chain.
Yeah. Cool. So we've talked a little bit about you said about your kind of experience with Stylus and the good docs and support and stuff. Is there anything more you want to sort of talk about? How it's been so far working with Stylus? Have there been any sort of challenges to getting started? What's kind of your experience been and getting stuff up and going, proof of concepts, that kind of thing?
Yeah. So I come with today 2 years of Rust experience, and I have roughly 7 years of Solidity experience. It's been pretty easy to get started with the basic proof of concept, and there's a lot of good examples to reference. And I got as far as setting up a local Nitro test node where I can deploy and interact with my Stylus contracts, which was really, really sufficient to complete the initial development cycles. I can expand also on kind of what my usual development workflow is. So
yeah, that'd be really.
So I usually organize my code into separate crates. So one that contains the core Rust logic, which doesn't even have Stylus as a dependency, and I'll touch on that a little bit because I think that maybe there's some room for improvement there from the tooling standpoint. So I have this core crate where I write let's say the core logic for the precompiles, and I also write the unit tests accordingly for this logic. And then I would have another crate that uses Stylus steps and also the core logic crate to build the Rust logic into a Wasm target. This kind of wrapper crate, if you will, is what eventually deploys the precompile as a smart contract as a target. And it's kind of like a proxy layer that is target specific. And then I've managed to decouple the core logic that is target agnostic, which allows for scalability in the sense that it's much easier to roll out more logic in the future. And if today we might only be supporting a certain curve, we can follow this rough pattern to roll out support for more curves in the future. And so talking about my development workflow, I would have this organization in place initially, and then I would make, whenever changes are needed, I would make the changes to the core logic crates, make sure unit tests pass always, and then spin up a local Nitro test node, deploy the Stylus smart contract, test again, kind of in the end-to-end setting there, and then deploy to staging and production as smart contracts, which is as easy as a one command run, right? Like with the tooling that you have today. And I can I can jump into the limitations and challenges that I've faced so far, and it also informs our decision to organize code in that way.
Right.
So,
I mean, it's a common thing we've heard about people doing a kind of a similar that sort of architecture, because it means that you can have unit tests completely outside of any kind of sort of blockchain notion, right? I mean, you've got your core code that really is just the core functionality, the algorithms that you're implementing, and you can unit test them on their own, which is great. So yeah, you mentioned about some of the challenges. Do you want to talk about some of the challenges that you've faced while doing this? Because this is something I think is going to be really, really interesting to developers getting started, because, you know, we'd love to say it's all perfect and fantastic, but of course we know that, you know, there's always challenges with stuff. So, you know, how has it been for you?
yeah, I'd love to talk about it, and hopefully this will push the Arbitrum team to develop, improve support for in the near future. So I mentioned, the organization, the specifics around how you would organize code. I've noticed that at the time, and this was, say, almost a half a year ago, I would say, when we were working with Stylus, there was a lack of a support with cargo workspaces, and there were some compilation issues. And when we were trying to, write multiple Stylus contracts into the same crate, and so that was largely what informed or pushed us to really split up into a really modular architecture. So that's why you would have the one, core logic crate, and then just a thin wrapping crate that would allow us to build into the WASM target as a Stylus contract. So that was one aspect. The other aspect is also that I mentioned, what helped was the variety of examples that was present, hand-holding me along the way. I will also say that it still isn't enough, even though there were plenty of examples and guides. This feel like there can never be too many. For example, we were trying to figure out how do you specify, in Solidity, when you would have a function argument that would take in a bytes type. It took me a long time to figure out that, okay, I should be using the bytes struct from the Stylus crate instead of just a Rust like a byte vec primitive. And so I think extra clarity there would be just having saved us a lot of time there. Secondarily, too, was how to declare Solidity interfaces. And so I didn't see much examples of that. And I think that's since then, I've noticed that there is a new playground that you guys have developed with a lot more examples. And so I'm quite sure that someone else caught the same issue of not having that guide.
Stylus by example, is that the one you're referring to?
Yeah, it's like a whole pink theme color. I saw it recently and I was like, damn, I really wish this was there at the time when I was developing it. But yeah, I think, minor hiccups like that, dealing with, or not being able to establish how you interact with an interface, a Solidity interface specifically, was a bit of a hiccup, and we had to just work our way around it. Our way to work around it was just changing up the contract to contract architecture, and instead we would just use a proxy router implemented in pure Solidity instead, separate from Stylus altogether. So we kind of just re-architecture solved that problem. Another one, I've got maybe like 2 or 3 more points if you allow me to in this time. One was about the 24 kilobyte constraint for Arbitrum contracts, and this is in general. This is not Stylus specific. This constraint required us to be really thoughtful about how or what code we write in Rust, right? And what dependence we need, right? Because you can't just be like, okay, well, I'm just going to import this huge Rust crate and deploy it as a Stylus contract. It's not going to deploy. It's, every line of Rust code that you write contributes to a larger smart contract. And so you're going to get closer and closer to that 24 kilobyte constraint. And so one technique that we really had to use is, on top of reorganization, is conditional compilation. So splitting up, okay, let's say we have 5 different curves you want to support. Each and every one of them would be conditionally compiled in this, and this is in the core crate, right? So now you can imagine you can have 5 wrapping Stylus crates. Each would call and would use that same core crate, but with a different conditional
Right.
flag, right? And so that allows us to be, from a code standpoint, it's still organized in the same core crate, but you would conditionally compile different pieces into different targets, into different Stylus smart contracts. And so I hope, and I know that the Stylus team is working hard continuously on this, how do you optimize down Rust code into WASM and then to take up just less space to provide more clearance from that 24 kilobyte limit. I really look forward to improvements in that field in general.
Yeah, I mean that's stuff that people have brought that up before and hit that, and it's kind of like, okay, Chris, I've got the whole Rust crate, ecosystem I can use, and then boom, right? You import something with a standard library, and suddenly you've eaten up that 24 kilobyte very quickly, right? So that's something that we are looking at. And if you run something like an Orbit chain, your own chain, then potentially you have the option to increase the size of that. But if you're running on a public chain, then that's you've got to fit within that limit there. So and we've actually got a fund for some Stylus within the DAO. That the DAO has funded a thing called a Stylus Sprint. And at least I believe that's just been funded, or it's imminently, maybe it's up for vote right now. I can't remember the exact status. But the intention of that is to work on a lot of this tooling. So things like optimizers, tool chains, that kind of stuff. Like you said, will make things a lot easier for developers kind of going forward.
Cool. And yeah, one last suggestion, if you will, is the experience of spinning up a local test node. Again, this is several months back. I'm sure you've come a long way as a team, as a tool since then. It was quite a lot of steps to spin up a local test node. And then so if we can really just make that a lot simpler, almost at parity with like a one-line command line, how you can just spin up an Anvil node. If you can just do that to a Nitro test node or just an Arbitrum test node in general, we can definitely bring our testing and local environments leaps and bounds to where we are today with Anvil right now. So that's just another piece of feedback that I'd have for you.
Cool. Yeah, that's I think that's something that again definitely could be working, more work done on it and get it even easier to allow people to spin up nodes themselves very quickly, especially in things like hackathons. People want to do that. They're at a hackathon. Certainly a very useful thing to be able to do easily, and we should try and optimize that further. So cool. In terms of what sort of development tools and frameworks have been, have you found helpful, building with Stylus?
Yeah, so I think being familiar with the Alloy suite of crates in general really, really helps. I did notice that, some of the primitives exported from the Stylus crates is actually a re-export from Alloy internally. And so that is to say that Stylus builds very much on top of Alloy. And so just being in general familiar with these primitives will allow you to recognize, okay, I should be using this byte struct as opposed to, something else or something like that's native to Rust, but actually isn't compatible with how Stylus likes to work. Another aspect that another I guess concept to be really familiar with and that would help is WASM, right? So when you're writing Stylus, you're writing Rust that compiles down to WASM and that gets executed by the WASM VM. Knowing how to build in a no STD environment is going to help as well, right? When you're needing to write Rust code that that works with arrays, let's say, you can use something like mini alloc, which is, I believe, also developed by Offchain Labs, and that's what we use right now in one of our precompiles. Is that WASM is very much a sandbox environment, and it doesn't come with a lot of. Even though you can literally write the STT code and you can import it, you'll find that it causes some runtime errors, right? And because when you actually deploy it, the VM, it won't support a lot of these primitives working. And so in place of that, you usually need to say, oh, let's switch over to using a mini allocator. That's what mini alloc stands for, right? There's a mini allocator for writing to vectors and arrays, and that's what we've had to do for our PKP precompile derivation code. And lastly, Stylus uses quite a few macros, and so I would suggest that, okay, if you're having some level of familiarity with how macros are used, how they're implemented, and honestly, if you're willing to go as far as, and it's not that hard actually, you can actually expand the macro out. It gives you full clarity for what you're actually dealing with, right? And I even would even say that sometimes and during the debugging cycles, I've had to do that to make sure, okay, the error is here or it isn't here. That's been super helpful. So yeah.
Cool. Well, that's really good. In terms of any kind of like resources that you've used, you mentioned awesome Stylus as well. No, Stylus by example we mentioned. But there's also things like awesome Stylus. What have you found, has kind of like helped you in terms of documentation, tutorials, libraries, individuals, communities, etc. For going forward?
Yeah, I've been noticing this trend where platforms, they would have these docs that are just full of examples, and I really, really like that. I will say again, there can never be too many examples, and I just want to be handheld. And developers these days, I feel in general, they just want to get to writing their POC and get things working. And so I definitely share that. I'm guilty of that, and so I'm guilty of not reading every single line in the docs. Having more examples really, really would help developers in general go a long way. And I'll say that, so you mentioned awesome Stylus. That's a great resource. Let's keep adding to that. Let's also keep adding to the web app, the Stylus by example. I want to call out key individuals that helped us throughout this process. So forgive me if I'm pronouncing your name wrong, but Masa Musavi, Mehdi Salehi, Jose Franco, these are really, really helpful individuals in our shared channel that have helped us build the POC and the production environment that we have so far in terms of how we can establish the Stylus contracts in prod right now. So
Yeah, they're great from Off-Chain Labs, and I've learned a lot from working with them, especially Jose and some of the tutorials he's done as well have been great. So that's really cool. So you've probably covered this, I think, but any sort of best advice or best practices or where to get started for devs?
I think that being really mindful, honestly, of if we were to take one thing away from the stream, just keeping your code really modular and small, because the 24 kilobyte limit really isn't much. And usually you're trying to do some kind of cryptography, I would like to think, when it comes to precompiles. And I guess obviously people have other uses for Stylus, but pertaining to precompiles, that's what I've noticed is that keeping code modular will help you go a long way. And so doing it early, otherwise, if you're trying to restructure later on with what is maybe a monolithic architecture, you're gonna find it to be quite painful. So get things right initially is my one piece of advice. And then just if you want to get started and don't know where to start, just go through the examples. I'm personally a huge advocate for practicing by examples. So try replicating initially. Just grab a couple of interesting ones from awesome Stylus, and then you'll, I'm sure, shortly have some inspiration for your own ideas, and then you can start building from there.
Brilliant. Cool. So kind of moving on to the future then, and sort of next steps. How do you see Stylus impacting the broader Web3 ecosystem?
Yeah, I think that it, in general, will just drive great awareness and conversion for people to use rollups, right? So being able to give that aha moment to people, being like, oh, rollups are actually giving me so much functionality at such cheap cost, at such speed. So that's the first thing, is that rollups are freaking cool and you should consider it. And secondarily is similarly like awareness conversion for people to use Rust. I think that Rust in general as a language, it's, every language has its own specific time and place. But when it comes to building what I'd like to think that most people are trying to build in blockchain ecosystem apps, right? That kind of security assurances that you would like to have and performance assurances that you'd like to have, it's a great language for that. It's really customizable. And so using that one language that comes with those benefits and then also being able to deploy smart contracts right out of it is game changing. And so I think that, I would even say as far as Web 2, right? Like Web 2, there's a lot of people migrating to Web 3, but don't know where to start, right? I think that Stylus as an initiative can really help convert some of those people to actually get cracking.
Yeah. The thing that I would add to that, just in the context of looking ahead, there's a lot of teams that are developing on Lit using the decentralized programmable key for the purpose of implementing chain abstraction. This notion that there's examples that are live and more on the way, some built on Lit, some with other kind of primitives, but to a place where a crypto user has a single unified and universal interface for interacting across a wide variety of blockchains. And so we've been in the era where blockchains are competing certainly on their feature sets, but also on things like vibes and grants and the community aspect of it. And now that we're in this emerging era of chain abstraction, which is to say, which includes things like gas abstraction and being able to access liquidity across many different blockchains, we seem to be moving into an era where blockchains and smart contract platforms are now more fundamentally assessed in a meritocratic way, which is what is the feature set that is available on this smart contract platform? And it becomes much more of like a B2B type buying mindset. And so being able to, with the capacity that Stylus has, I think that's pretty advantageous for Stylus to kind of ride the wake of the mood and the trend of chain abstraction, which in general is a pretty amazing thing for the space and something that we've been so excited to support teams that are building in that direction.
Yeah, I mean, that's the whole point about sort of, as Howard was saying about rollups there, is like up until now, I guess in most cases, rollups just kind of like, well, it's just how you go a little bit faster, a little bit cheaper, right? Then there's been some rollups that have like very, very specific functionality for a very specific reason. I think Stylus hits that really nice sweet spot where, no, you do actually now have, some enhanced functionality to do stuff using Arbitrum as a rollup in a Ethereum style, but functionality beyond what you can get from Ethereum itself, right? There's a genuine reason to use a rollup besides just the performance and the cost. There's actual functionality reasons there as well. And like you said, bringing people in with Rust experience, if we can start appealing to, other communities, gaming, AI, etc., because, if they're compiling down to WASM as well, maybe if you had a Unity developer in C# compiling down to WASM, that could be really interesting as well, or a AI developer writing, Python compiling down to WASM or whatever it might be. I think that is a really powerful like value proposition for building. And you want to build where things are going to continue, right? You don't want to be left high and dry. And I think that's the really cool thing, is that it's not, Arbitrum and Stylus is not just like it's not like a niche chain trying to do just one particular thing. It's something much broader. So I think it's got the longevity and it's got the ecosystem there. It's got people like you mentioned, David, about liquidity and all of that kind of stuff in there as well. So, you've got people building there. You've got the ecosystem. You've got the communities. You've got everything all the way down to the memes, to the DeFi, to the AI, to people like yourself building on top of Stylus. So that's really cool. How do you anticipate Stylus is going to help you scale and expand Lit even further now?
Yeah, so to date, we have already built our new set of precompiles for the K256 curve, and we can imagine doing so for any number of curves out there, right? We're talking about just, what do we have in Rust today when it comes to cryptography, right? Like there's been we've been developing on Rust since long time ago, and so we can tap into that ecosystem and just bring that over to a chain perspective in the form of a precompile, right? And so we're looking ahead. When we're looking ahead, we're looking at, okay, how do we provide greater access to these curves in general throughout the network, right? Like building out more precompiles for these curves means the lit nodes themselves can also support these curves. And it's not just for the end users to leverage this too. This also means that for some signature schemes that we can't currently verify, we now are able to. I'm talking about, for example, our Ts. They provide attestations, right? And attestations include in them a signature. And so being able to take our verification of these attestations of these Ts to the next level, i.e. like putting, whatever commitment or whatever signature you want to chain and then having it successfully verify on chain through the precompile is the next level. And it's a great level to be at, right? Like it's great transparency and proof to everyone in who's using the network to be like, hey, you're using these nodes, they are attesting to the fact that they are running this, piece of code and their memory state was this at this particular moment during boots, right? These are all very important information. The average layman will not be tapping so deep into it, but when you do want to look and when you do care about it, it's going to be there, and that's going to be really helpful for those people who really want to have that assurance, right? And there's a whole unlock there where we can start to think, okay, well, is there going to be some sort of governance structure that kind of looks and taps into and monitors these attestations too, right? And so having that unlock from being able to support more precompiles and more curves is one of many ways we are going to expand the protocol in the near future.
Cool. That's all really exciting. So anything else, David, from your point of view in terms of kind of like future and scaling that you want to mention at all?
No, just that, as mentioned, we've had the LIT mainnet beta up since February of this year. It's currently one distributed key management network. The scaling plan is a horizontal scaling plan. We envision a future key mesh. And so, yeah, just being able to leverage Stylus and Arbitrum orbit chains are super important in that future as programmable decentralized secrets and authorization and agents start to be pulled forward from the future into our present day.
Yeah, exactly. Reach into the future and bring them here. So so where can users try out the LIT protocol then? Yeah,
just litprotocol.com. The docs are there. We're a super responsive team. It's a new primitive, this notion of a confidential programmable secret. So we love meeting people with like novel and creative ideas. And it's just the absolute best to get to work with people who have a deep insight around where the future is going, and we can work on it together. So yeah, we love to hear from folks, and thanks everybody for tuning in.
Cool. That's fantastic. Thanks a lot for coming on here and talking about LIT. I knew a little bit about it, but I didn't know half as much as I do now. So that's really cool. And it's great to see how you're using Stylus and how, we can stand up here and talk about stuff, but I mean, the fact that we've got, projects here that are actually building upon this stuff is really cool. So it's great to hear from the developers, what's working, what not. Some great feedback there from Howard as well. So hopefully we can get some of those more examples. We'll get more examples for you in as well. So that'll be really cool. So for anybody else at the moment wanting to try out Stylus, you can go to arbitrum.io. We've got you can click on Stylus there. There's information there. docs.arbitrum.io. The docs are there. Stylusbyexample.org, I believe it is. It is there. There's the awesome Stylus link. All of these links hopefully will be in the notes of the recording afterwards as well as the links for LIT for people to go and check out LIT. So that'd be cool. Are you folks going to be in Bangkok for DevCon or ETH Global Bangkok?
Absolutely, yeah, and we're also sponsoring the ETH Global Bangkok as well. There'll be some prizes for Lit. Maybe we can coordinate out of band and see if there's anything that we could put together around mutual grants and prizes.
That'd be great. I love doing this. I love when, especially things like ETH Global, because there's so many projects there that are represented. This one's meant to be huge. I think they're aiming for sort of over 2,000 people there, and I think the total prize pool is like $800,000 at the moment. It's good. It's their largest one yet. But I love doing collaborations with other projects, so it's great. I'll be there, and some of the other team from OCL will be there, and from the Arbitrum Foundation will be there as well. So maybe I'll touch base with you guys and try and see if we can do something together there, because that'd be really good. Getting people using both Lit and building stuff with Stylus, because we're gonna be pushing people to build on Stylus as well. So really cool.
Super exciting. It
Fantastic.
happens one day at a time.
Yeah, great. Well, thanks, Howard and David. Great to have you on here, and I'll see you in Bangkok hopefully.
Thanks for having us.
Cool. Bye.
Hey.